Welcome to today's explainer. Okay, we're diving straight into the heavily regulated and honestly absolutely fascinating world of ASME certification. Look, if you're an engineer, a manufacturer, or just someone who respects the incredible forces contained within industrial equipment, you know that a pressure vessel without proper certification is basically a bomb waiting to go off. The certification is literally the essential passport for pressure vessels. And today, we're going to decode exactly how the whole thing works. Take a look at this famous cloverleaf. It acts as the ultimate global symbol of manufacturing safety. Without this specific mark applied to its metal shell, a pressure vessel simply cannot travel into the real world to do its job. It really is the gold standard of trust. Now, to keep us from getting lost in the technical alphabet soup today, here's our agenda. 1. The standard of safety. 2. Decoding the designators. 3. Applying the physical marks. 4. The essential data reports. And finally, 5. Parts and special cases. We're going to use this as our mental filing cabinet to build our understanding step by step. All right, kicking things off with Section 1, the standard of safety, the global passport for pressure vessels. We've got to establish the absolute baseline terminology here for the ASME Code. The crucial point is that using this mark requires formal ASME certification. It is fiercely protected. The code explicitly states that if you aren't certified, you can't even implicitly claim your product is ASME approved on any of your forms or documents. There are no shortcuts here, no close enoughs. It's a completely binary system. You either meet the standard or you don't. Moving right along to Section 2, decoding the designators. We'll be looking at U, UM, and PRT81. So how does this actually break down? Well, the cloverleaf is usually accompanied by a specific letter or set of letters. Think of it as a taxonomic map. The U is for your standard heavy-hitting pressure vessels. The UM stands for miniature vessels. And PRT811, that's used exclusively for prefabricated parts that are going to be assembled into a larger vessel later on. Now, you're probably wondering, what exactly makes a vessel miniature? It's not a guess. There are extremely strict volume and pressure limits to qualify for that UM stamp. For instance, they max out at 5 cubic feet if the pressure is 250 psi. But if you bump that pressure up to 600 psi, your volume has to drop down to 1.5 cubic feet. If a vessel exceeds these very specific limits, it loses its miniature status and bumps right up to the standard U rules. Okay, Section 3, applying the physical marks, or how to actually prove it on the vessel itself. So when this is applied directly to a vessel, the specific U letter is tucked neatly right beneath the main cloverleaf. It's clean, it's totally unambiguous, and an inspector anywhere in the world will recognize it instantly. But hold on, you can't just slap a stamp on a piece of metal because it looks finished. There's a super specific procedural journey here. The physical mark is usually applied only after a hydrostatic or pneumatic test. Basically, blasting it with pressurized water or air proves the vessel won't burst under pressure. Only when the metal survives the test does it earn the stamp, which is then immediately followed by the final paperwork. And it's not just the symbol. You literally have to stamp the vital stats right where an inspector can see them. We're talking about the MAWP, or maximum allowable working pressure, the MDMT, which is the minimum design metal temperature, the manufacturer's serial number, and the year it was built. These numbers form the literal operating boundaries for the entire life of that vessel. Which leads us to Section 4, the essential data reports, the paperwork behind the stamp. Think about this for a second. We have the physical hardware marked, sure. But how does an engineer physically track the history, the exact materials, and the inspections of that specific vessel, say, 10 years from now? The answer to that is the U1 form. Every single U-designated vessel has to have one of these exhaustive manufacturer's data reports. It details the design, the materials used, the construction methods, and it legally has to be signed by both the manufacturer and the National Board Authorized Inspector. It is, for all intents and purposes, the birth certificate of the pressure vessel. Of course, depending on what you're actually building, the required paperwork shifts. We've got the standard U1, but there's also the U1A for single-chamber vessels and the U1P for plate and frame heat exchangers. If you're just building a part for someone else, you use a U2 partial data report. And those miniature vessels we talked about earlier, they get a U3 or U3A certificate. The whole system is perfectly designed so the documentation matches the complexity of the hardware. For instance, the U3A is the specific certificate of compliance used exclusively for those miniature vessels. Because the vessels are smaller, the process is slightly different, but I assure you, the documentation is no less rigorous. It's also super important to note that for these miniature vessels, the final sign-off comes from a specific certified individual, or CI. Now, the CI is an employee of the manufacturer, but their qualifications are strictly defined and audited by the ASME Code. They provide the necessary oversight to ensure that the stamp is applied correctly every single time. And finally, Section 5, Parts and Special Cases, going beyond the standard steel shell. What if you're making prefabricated parts that'll be shipped from one manufacturer to another to be welded into a final vessel? Well, those parts have to bear this specific PRT VII stamp. It's often accompanied right there by the word part and is heavily backed by that U2 form we just discussed. This setup allows the final assembler to trace the pedigree of every single component. The code is also amazing because it adapts to extreme engineering. If you're using high-tension steels, you gotta add the letters UHT right below the main mark. For low-temperature construction, you use ULT. And if you're building something like a submersible with cast acrylic windows, you use the letter A, which ties into an entirely separate safety standard for human occupancy. Wild, right? It even has rules for materials you'd never normally associate with pressure vessels, like graphite. Because you obviously can't stamp brittle graphite without shattering it, the code allows for permanent cement impressions directly on the material if a standard metal nameplate is infeasible. Talk about cementing your compliance. They've literally thought of everything to ensure that mark makes it onto the vessel. So what does this all really mean? When you think about the immense, terrifying pressures these vessels hold in power plants, in submarines, in chemical refineries, how does this strict global taxonomy actually prevent catastrophic failures every single day? It's because it leaves absolutely nothing to chance. It demands a paper trail for every single weld and every single pressure test. Next time you see that cloverleaf, ask yourself, what intense journey did that piece of metal have to take to earn it? Thanks so much for joining me for this explainer. I'll catch you next time.